Hello, everyone, and welcome to today's webinar on the PTC Creo Simulate Extension. It's one of the more powerful extensions part of the Creo Design Premium package. My name is Alex Janicki, Director of Marketing here at TriStar, and I'm very pleased to introduce our presenter, Emily Pinto. She's a virtual pre-sales specialist at PTC. Before I get started, I just wanted to do some quick bookkeeping and mention that a complimentary recording of this webinar will be sent to everyone who registered automatically, as well as available on our website and YouTube channel shortly after the presentation. If you have any questions during the presentation, please feel free to leave them in the chat, and we'll hold a brief Q&A at the end of the presentation. And before I pass it over, I did want to briefly go over TriStar for any of you not familiar with us. So at TriStar, we're a company that specializes in helping manufacturing companies adopt systems and processes to enable better and more efficient product development. We achieve this by being the largest value-added reseller for PTC products and services worldwide, with headquarters in Phoenix, Arizona, and representatives and engineers throughout North America, Canada, and Mexico. We've been in business for over 25 years, and we're experts in CAD, data management, PLM, and product development. We also have a large assortment of custom solutions, services, and support packages tailored to specific requirements and needs. And one final note before I pass over the reins to Emily, if you like what you saw today, we've been, or just kind of been waiting to upgrade, I did want to mention we have a time limited offer of 30% off all Creo extensions running to the end of the quarter. And you also may notice in the handout section, there are two data sheets. One's on the Simulate extension and the PTC Advanced Simulation extension that you can kind of take away, view after the presentation, and just goes into a little bit more detail. And without wasting too much time, I'm gonna go ahead and make Emily the presenter here. And in just a moment, she's gonna share her screen.
Okay, hi, I'm just trying to figure out how to share my screen here. Alex, I don't know if you know what icon I'm looking for.
You did share the screen. I think you just need to swap the monitors.
Okay. I see. Okay, got it.
Yep, there we go.
Okay, so you can see my PowerPoint?
Yes, I can, ma'am.
Perfect. Okay, so hi everyone, my name is Emily Pinto. I work with PTC in a group called the Virtual Center of Excellence, and I am happy to walk through the Creo Simulate extension today. Now, Creo has a lot of different capabilities for simulation and analysis, including simulation analysis even for, prepare for manufacturing and things like that. But what we're talking about today is our FEA solution that's been in Creo for a very long time. So this is the analysis engine that Creo has used. It used to be called Mechanica, if you're familiar with that. And it does all of your FEA analysis, so thermal, modal, structural, whether that's dynamic or whatever it might be. And we'll get into all of the capabilities as we go forward. So this is going to be for your validation analysis, but the great thing about Creo Simulate is it's so easy to use and it's integrated so seamlessly into your Creo design environment that you're able to set up your simulations early and then check as you're modeling, check to make sure that you're getting the responses that you'd like so that you don't have to do rework later or anything like that. And so the aim of Creo Simulate, where PTC focused on Creo Simulate solving challenges, is that we saw out in the industry a lot of engineers and product development companies. They see analysis as something that the experts do, right? It's highly detailed, you need to make sure it's correct, so you send it off to another team. But the problem with that is that it takes a really long time, and it's often very expensive to do. And because of that, you only use it when you absolutely have to, right? You're testing a virtual prototype after it's been completed to catch the problem. So it's done very late in the process because, if it's not an easy to set up simulation or you're sending it to analysts, you think, oh gosh, okay, let's not waste too much time doing this, over and over and over again. But what ends up happening is if you do use it to catch problems at the end of your design, you're really not designing based on these analysis results. So it's not an analysis driven design, it's just a virtual prototype. And so it doesn't really guide your design decisions. It just tells you, does this pass or fail? Basically, did you mess up anywhere? And then this is gonna break on your customers. And so it's really not the most effective way to use analysis, especially in this day and age. It's we have a lot of analysis tools, and so you want to make sure that it's driving your design. So easy to use, early analysis, but it's still a validation tool. So you have all the power of those high fidelity solvers that you use as validation. So our solution, Creo Simulate, you can do structural and thermal analysis to understand product performance, optimize your digital designs. Optimization is a really great thing to do with Creo Simulate, and we'll get into that in the demo. We have, a completely integrated user interface, location, the whole intelligence and associativity. It's totally integrated into Creo. So you're designing on your model, make a bunch of changes, or maybe you make a single change and you say, all right, is this gonna, is this a useful change, or am I hurting my design? Open Creo Simulate, rerun your analysis. And if you make any changes in the model, your analysis model obviously updates this as well because it's done right on your same model. It's the same model that's used for design and analysis. So you enable designers to make better decisions earlier because you can set it up once and then run it as you're investigating different options. One of the other great things about Creo Simulate is that you can conduct optimization and feasibility studies. So once you have your analysis run, you're able to run optimization studies. And there are 3 different types, and they tell you slightly different things, but basically you're able to select a set of parameters or driving dimensions and tell Creo to vary those through a certain range, right? You set the range for each of those different dimensions. And then it tries every combination to try to minimize against the goal that or maximize something that you're trying to model against, while maintaining stress levels under a given amount or deflection under a given amount. And it'll tell you what's the best configuration for the dimensions that you gave it in order to reach your goal and also meet your analysis requirements. So you get to not just an answer like you might if you're using it just once at the end to validate, but you're getting the right answer because you're driving your design with these results. So we have a lot of different results, and they're broken up into, a lot of different types of analysis, and they're broken up into a couple different packages, which we can talk about in a little bit. But your static structural, that's your standard buckling, steady state thermal, nonlinear contact, materials nonlinearity. So you can do contact analysis and use hyperelasticity and plasticity. Isotropic and composite materials are something you're able to do as well. So you just fill out your material card. Any material that you put into Creo and you assign to your model, that can be used in Simulate, as long as you have the right parameters filled out so that it can run the analysis. Large deformation nonlinearity, dynamic and pre-stress analysis, and transient and nonlinear thermal analysis. So whatever type of dynamic or pre-stress analysis you're running. We also have a fatigue analysis that is incorporated in the Creo Simulate user interface, but it is sold separately. So if you're interested in fatigue, it would be a similar process as we're going to see here today with Creo Simulate, and it would, you set it up the same way, but you have to make sure you have that capability in your licensing. So the great thing about Creo Simulate, my favorite thing about it, is that it's a P-element mesh. So the meshing is really, really effective. So we have automatic and advanced meshing tools so that it'll go in and make the mesh for you, and it'll make sure that in areas of small geometry or quickly changing geometry, it's going to refine the mesh, and areas where it's not changing very quickly, it'll make the elements bigger so that you're not taking up computational power that you don't need. We have idealizations. If you're, want to run an idealization instead of actually mapping out, having it wrap the mesh around the geometry, this can be, much faster and simpler to do if it approximates your model well. So we have support for solids, shells, beams, springs, masses, and of course, once you've done your auto mesh, if you would like to override any aspect of that with user controls, you can use the pretty granular level of manual meshing. So you can place the nodes where you want or change things if needed. So you still do have control over it. Use the auto mesh when you'd like, and if you want to make changes, the manual's there. You're able to conduct optimization and feasibility studies to improve your initial designs. You can answer what-if scenarios using sensitivity studies, and then vary your properties in your simulation model. So this is what we were talking about with the optimization, and we'll see that in the demonstration. Outputting your results, you can set up results templates so that anytime you run a model, the things that you like to see and how you like to see them pop up, they're usually concerned with stress or displacement. Those can be automatically filled out for you in a template. If you'd like to obviously make changes, once you have your results open, you can add windows, change them, whatever you'd like to do. You can output all of this as an MPEG, VRML, Excel, TIFF, and HTML reports if any of those are useful to you. And you're able to query on the values if you click around. So there's never anything where you have to figure out, if you want to know the value at a spot, you don't have to try to figure out how to get that to display on your results. If you just like to click there, it'll tell you the result value. So you can also plot fringe, ISO, vector, and graphical results. So if you need anything graphed, not a problem. There's a whole host of, I'm just going to mention this here in case I forget it during the demo, but there's a whole host of result types that come out of the box with Creo Simulate that you're able to say, all right, I want to see, my result of force in the X direction, or my displacement or principal stress. But you also can set up user-defined results. So if there's anything that you want to measure that happens not to be in, the list of things that Creo already out of the box solves for, that's not a problem. You can add user-defined values or measurements and have it display those as well. So. Alrighty, if there are any questions, please put them in the chat. And then Alex, if you see anything that you'd like to stop me, you can go ahead and jump in, cut me off, while we can talk about questions.
Absolutely, yeah. As she mentioned, just feel free to put them in there. If it's related to something she's showing on screen, I'll let her know and we can dive into it. But otherwise, we can answer them at the end of the presentation.
Okay, so we're going to take a look here at Creo Simulate. This is an example. This is a demo done in a slightly older version of Creo, but the workflow is the same. We make improvements with every release of Creo, so productivity improvements or UI things, but relatively similar. It still applies, today. So. Up in the applications tab, you can see we're going to work on this lifting lug for this piece of equipment. This is the standard application for it, but for this example, what if we want to use it for something that we're not so sure about, or we would just want to see if we can improve it? It's been something that a lot of times companies have parts that have been in the system for 10, 15 years, and with all of our analysis tools that we have today and how easy they are to use, it's worth going back and reevaluating some things to be optimized and updated. So Creo Simulate's just in your applications tab, and it's just an extra tab. So basically it just launches an extra couple of tabs there for toolbars for you. And the way you can work is left to right. We try to set it up that way. So you'll see in the setup right under the home tab, you have the option for structure, thermal, or modal. And if you select those, the appropriate loads and constraints and types of buttons that would apply to those different modes would appear here in the toolbar. You have your loads here this is the structural simulation, so force, moment, pressure, bearing, preload, gravity, they're more in the drop down. Constraints are the same, right? Pin, ball, displacement. You can assign your materials right from here if you haven't assigned them already. And you have then your analysis and results right at the end. So to just get an idea for how these are applied, you can see that adding a constraint, you can choose to add it to a constraint set. So it'll say, right, you can see there member of set, constraint set 2. The nice thing about this is by setting up different constraint sets, you can have multiple different loading conditions and constraints, available in different sets, and then you can decide which ones you want to apply to a particular analysis. So if you have a couple of different ways that this might be loaded, you can mix and match if you want to run it just the one way or run them all together. That's an option. So first thing it does, it just asks you for a reference. So what are we going to constrain? Is it an edge, a surface, or a point? And then you can choose your coordinate system. So if it's a custom coordinate system, and then choose if you'd like translation or rotations. These are just going to be fixed right here where they are. And then you get that little indicator that you've put constraint 1 is a displacement constraint, and they're just sitting there where they are. So force, if you want to apply a force, same thing. This is going to be part of a load set, and it automatically chooses the load set for you if you set one up. So if you forget that, it's not a problem, but you choose the surfaces, choose surface sets, and then add in your magnitude and direction or your components. And then if you'd like a more advanced type of application, you could change it from total load to force per unit area, total bearing, load at point. For this one, it's going to be total load at point, and the point is this coordinate system that was previously defined, or sorry, this datum point that was previously defined. When you put the force components in, right, -20, you get kind of this twisting motion because the point is farther away off to the side. So you can see that load, that force was applied to both of those surfaces for the inside of the holes, and it's kind of going to put a little bit of a torque on that. Now to run the simulation, once you have all your constraints and load sets set up, it's very easy. You just go into your analysis and studies, and to add a new one, you can see this analysis and design studies box is empty. Means that we don't have one chosen yet for this part. Well, you can go in and choose which one you'd like. So this is where, if you have Creo Simulate, just the standard extension, or if you have the Creo Simulate Advanced, this is where you'll see some differences. So if you don't have, for example, the advanced package, the new dynamic study option will be grayed out. But you get static, modal, buckling, fatigue. So that's if you have the fatigue analysis in your license, that you'll be able to select on that as well. Pre-stress, dynamic. You can see, for an example, the dynamic is time, frequency, shock, or random. So this is really the difference between Creo Simulate and Creo Simulate Advanced, is that with Advanced you get some more options. So the workflow is the same, even though we're not showing any particularly advanced capabilities today. The workflow still applies, right? It's just instead of choosing a new static analysis, you choose something that's a physics type that's only available in the advanced. So works the same no matter which package you have. And of course, the analysis definition will change. So for the static analysis, this is what it looks like. The more complicated your analysis is, the more information you might need to fill out on this analysis card, just in order to tell Creo, really what you want to see. So if you wanted to use nonlinear or load histories, you can check that box. Inertia relief, right? So that's how you would turn on some of those more advanced capabilities here. You can combine your constraint sets with that checkbox. Right now, we only have one constraint set selected and one load set selected, so we wouldn't want to combine them or sum them because it's just the one. Now down here, this is where the P element mesh really comes in handy. So my favorite thing about Creo Simulate is if you put an auto mesh on your model or a manual mesh, however you get your mesh onto your part, And you need to refine your results. You don't actually have to refine your mesh in order to get a more refined result. So what the P element mesh does is it basically does more math per element if you use a higher polynomial order. So that's what the P stands for. And because of this, because you don't need to change the mesh to do more calculations per element, you can do something that's like single pass adaptive or multi-pass adaptive, which means that Creo Simulate will run your analysis. It'll get your results, and it'll run it again, and especially look at where there's high stresses and or high values, things like that. It'll refine it where it needs to refine it, and then it'll check to see if those results changed from one study to the next. And if the results changed a lot due to the higher refinement of the calculations, then that means that you still may need to refine. So it'll keep rerunning areas that need to be refined until your results converge. So it actually checks to make sure that your results are converging before it gives you the results. So you can control that here. So the polynomial order, that's just how many calculations, it essentially relates to how many calculations you're going to do per element. So you start maybe at just one, your standard kind of analysis, right? You do it at every node. And then if it needs to refine it in those areas, it can go up to 9, 9 per element, so, or per edge technically. This was a very approximate way of describing the P element, but hopefully, just trying to get across the what it means for your model, right? This isn't exactly how it works, but this is what it means for your results. Now your percent convergence, that's what you're going to determine, hey, consider it converged if the results change less than 6%, consider that basically, that it's the same. So, and the nice thing about this is that, so this is just running, you can have a little log. But the nice thing about that is that you don't have to refine your mesh over and over again. You don't have to worry about bad elements or something when you make smaller elements, because you're not really changing the size or the shape of the element. So it's a really, really useful tool. And when you get the results back that they've been converged, you don't have to go back and run a more detailed analysis in terms of your meshing. So seeing the results is pretty straightforward. You can animate, change stress, strain, rotation, shell, P level. You can control your legend if you want to show everything over a certain value is in red, right? You have the top shell of the bottom. So a couple of different ways to see that. Now, getting the analysis results is great. You can tell whether or not it's going to work. If you do it early in the process, you know whether or not it's going to work before you start adding a bunch of changes. So you can kind of keep tabs on it along the way. Again, if you make a modeling change, it'll show up here. If you use this as a simulation model, if you've done any simplification to it, using a one-way associative model or an inheritance model is a good idea, because then if you make changes in your regular model, they'll show up here, but you can keep it simplified. But the really nice thing about having these studies done is that you can run sensitivity and optimization studies. So you don't have to guess what values to change to make changes, impactful changes to your model. Running a sensitivity study is going to tell you how much a single parameter is affecting a measurement or goal that you have. So you start with the analysis that you just ran. It needs those results and those study settings to figure out what's going to be affected and what your stresses and displacements would do. And then you choose the dimension or the parameter that you want to see how the effect is. So this is where you put in that range, so 0.1 to 0.5. How many steps in between those two values do you want to see? And what are you gonna model against? So this is pretty quick. It uses that analysis to do that. So it's already been run, so that's pretty fast. And then this is to set up your results for the sensitivity study. So if you want to see this as a graph, and this is where you pick the measure. So that inner radius, basically what we're saying is, what effect does varying that radius have on one of these measures? Like I said, you have a lot of measures that come with Creo right out of the box here. So you can just select one of these, or you could have a user-defined one if you have a user-defined. So we want to see the radius effect on the maximum von Mises stress. So you can see here what it does, you know, at each of those different values of the radius, what the stress would be. This gives you a really good idea if you're trying to get to a certain point, you know, does varying this parameter, even if you go, you know, if you multiply it by 10 times, is it ever going to get you to the value that you want? And so that'll tell you, before you waste a bunch of time varying parameters, find out if they're really driving the values that you're looking to change. Or maybe before you make a big change, you want to add something in quick, you know, take a look at whether or not that spot is going to have a big effect on the results that you're, you know, that you have. Now, another option is the optimization design study and a feasibility study. You could choose here as well. Feasibility just tells you if it's possible. Optimization tells you what your model would look like to get you to that goal. So the goal here, right, you can minimize, maximize a particular measure, and then you can choose your measure there. So if we want to keep the mass minimized, and we want to have a couple of rules, so we do not want our stress to go above some certain value. So you can put that in here. And maybe we also don't want our deformation or our deflection to be above a certain value as well. So you can put that in. So it's going to try to find the model that has the least amount of mass that still meets those rules. And then what parameters it's going to be able to change in order to get to that model is what you choose here. So you just go into the model and select the surface or part that you want to pull the driving dimension from, and then put in the range. So this is that inner fillet. And you can choose as many variables as you want, right? Maybe some have to be, maybe some you know have to be a certain value to fit with the rest of your assembly or work in the application. But there's a lot of these values that, especially for something like a lifting, like it doesn't matter how wide it is here, you know, as long as we have enough room to weld it on or whatever it is that you're going to use to attach it. So you can just go through and click on the model and click on the driving dimension, and then put in the range for all of them. So it does tell you your current, so that while you're sitting here in your table, you know what the current value is. And then you can vary it on either side of that. So maybe this can go from 1 to 2, and this could go from 1.85 to 2.5. The angle, it doesn't matter what the angle is as long as it's, you know, not less than 90 degrees. And now, instead of using Simulate to run the analysis and then go to your model and see if you can optimize it and come back to your analysis and go to your model and see if you can optimize it, you know, the only things that you'd have to do that type of iteration for, if you can do the optimization in Creo Simulate, have Creo run through all those iterations. Now you have, you know, the option for when you're making changes, it's not to optimize what you already have, but to add to it or improve it. And so you use Simulate to go through all those iterations that an engineer might be tempted to do, to say, all right, well, you know, what are all these dimensions doing? How do I get more strength out of it in the same size? Or how do I get less mass out of it for the same size? And so you can actually see the results here. The study's done. You know, the stress is right there, and it's a shape that you probably wouldn't have come up with even if you had gone back and made changes and rerun the analysis, right? You can see different options that Creo comes up with, so you don't have to do that manual task. So it's not any harder to see your results as it is to optimize them. Now you can step through it, right? This is how it got to the solution that it got to. Step through and see all the different values that are changing. Gives you some idea for maybe where you want your model to be. But the value of this, right? Talking about why is this useful? You know, great, we have a simulation tool. You know, everybody, I think everybody at this point understands why simulation could be valuable, but whether or not it's feasible or useful for your process, you know, the things that you have to try to figure out are, you know, do we need our analysis results? Are you doing a lot of prototyping where a high fidelity detailed simulation would be able to knock out some prototype iterations? Would running a sensitivity study and an optimization study be able to knock out, you know, a week of back and forth trying to improve a product? Being able to quickly add features and evaluate all the different ways that you might be able to place that or use it on your model while getting the most out of it, so you can evaluate, hey, is this something that we want to do or not, without having to take a week to iterate through every option that you might have with it. So, you know, the customers that have adopted Creo Simulate, what's the value? You're able to use this early because it's easy and it's associative and it's right in Creo. So you're able to discover design flaws earlier. So you actually have an increase in first-time build success. You understand what your model is doing. You've done it in a timely manner so that you don't have to go back and just try to rework it so that it doesn't fail. You're able to identify those earlier and then rework your design, you know, before lots of changes need to be made and decisions have already been decided. Reduce or eliminate the need for physical prototypes. And we saw a very simple analysis today, but you can get very granular with Creo Simulate. You know, we keep it the user interface relatively simple so that if you don't need to get granular, it's not overwhelming you with buttons and options that you might not need. But if you do need to get really detailed, you know, you have those options in those windows that you can open when you select on those types of analyses. You can also leverage the analysis and optimization to reduce material cost. Just running a simple analysis and optimization might be able to reduce, you know, if you run an optimization like that on every model that you have and reduce it by even, you know, 5%, 10%, that's a lot of material savings if that becomes a regular part of your process. Lower lifecycle costs, you're able to reject designs before costly prototypes are reduced, discovering flaws early. It's, you know, much cheaper to discover design flaws earlier. You're able to decrease costs associated with long product development and review cycles because you can speed through some of those iterations, optimizations, and prototypes. And you can reduce aftermarket service and warranty expenses because, you know, recalls or warranties are very expensive and you really don't want your customers to have to go through that anyway. So knowing that your model is going to work in all the conditions you expect it to be used in makes a big difference for whether or not, you know, you can assure your customers that it's going to do the job they need it to do. So this was all I had to show today for Creo Simulate. Like I said, it's a relatively straightforward process. It's a really useful tool for eliminating design iterations and understanding your product early so that you don't have to make changes late in the design process when they're much more expensive and time consuming. Simulation versus advanced simulation. So every seat of Creo comes with what we call Simulate Elite. And that's just your really basic structural analysis for parts and assemblies. So if it's anything more than a really standard structural analysis, you know, most people who need a simulation tool come, you know, to the simulation extension or the advanced simulation extension. But if you're considering whether or not analysis would be useful, you would have the static to play around with. The division here really comes, this has all the idealizations, it has steady state, thermal, modal, structural. You have that optimization tool that we saw running the optimization studies is part of the standard. So idealization, yeah, optimization, and then the nonlinear contact as well. But if you'd like to get into materials nonlinearity or large deformation nonlinearity, that's where you get into the advanced. Same with the dynamic analysis or transient nonlinear thermal analysis. So if you're going to do any kind of vibration or shock or anything like that, that would be your dynamic analysis. And again, you have the option for isotropic and composite materials in the advanced simulation. So if you do anything with isotropic, that would be where you would be. All right, you know, I think that about covers everything we were going to show for today. Alex, I don't know if you have the chat. Okay, perfect, thanks.
Yes. Thank you, Emily. Well, I'll pause briefly for questions. While we wait, if you enjoyed this presentation, I definitely encourage you to share the on-demand recording with colleagues or on social media that you will receive shortly. It'll also be available, like I said earlier, on our website and YouTube channel.
And if you have questions about whether or not simulation would be useful for you, if it would be able to save you time or money, if it's worth, if it's worth doing, that's what we're here for. We have conversations with people, every day talking about what's your process and, what benefits do you think you would see personally out of running simulations like this, and what extension might you need. So please, if you have any questions, feel free to reach out. Alex is probably quicker at responding to those, but if you have my email, that's fine too.
Yeah, definitely. I don't know if I can answer this question. Definitely feel free to reach out. Emily, you may know.
Yeah, we could.
The question is just how much would the advanced simulation package cost?
That's a good question. Yeah, I don't have pricing information, so we might have to follow up on that one.
Yeah, we definitely reach out to us because in addition to the discount that we're offering this quarter, it's going to be 35% off just for any extension. But we can certainly answer that question if you just reach out to a TriStar representative. And with that, I believe those are all the questions. So I just wanted to thank you, Emily, and thank you everyone who attended. Definitely visit tristar.com. You're going to find additional webinar replays, more information on our various extensions and packages, as well as free trial links to Creo 8. So with that, thanks again, everyone. Thank you, Emily. I hope everyone enjoys the rest of the Thursday. Have a nice Friday and a great weekend.
Bye, everyone. Thank you.
Thank you so much. Take care.